Hi, what are we going to be talking about today?
We're going to be talking about how to identify acids and bases, which is really fun. It's actually one of my favorite things we talk about in chemistry.
All right.
Acids and bases, oh yeah.
Aren't acids dangerous?
They are, but not always. Not all acids are dangerous. Some of them are.
Okay, well, I guess if I'm going to be dealing with something that's kind of dangerous, I got to know how to tell what it is, right?
Yeah, you want to be able to identify the dangerous ones, right?
All right, so how do I tell?
Yeah, we got to talk about what makes an acid an acid. Well, an acid is anything with a pH that's less than 7 or from 0 to 7.
Okay, all right.
That's first of all. You've heard of the pH scale before, right?
Right, yeah, I've heard of that before.
So anything that's from 0 to 7 is going to be an acid. 7 tends to be neutral.
Okay.
And then 0 is like really, really, really acidic. And the closer you get to 7, the closer you get to neutral. Like pure, plain old water is neutral.
So that's kind of backwards, because I like to think of big numbers as being more of something, but on this, a small number is more acidic.
Right.
Okay. All right. So something with a pH of 0 is really dangerous.
Yes.
Got it.
Yeah, it's very, very
acidic. All right. So what does that make the pH for bases then?
Bases will be from 7 up to 14. 14 is as high as you can go.
Okay. All right.
So from like really, really close to neutral to really, really, really super basic.
Okay.
So basic, we don't mean boring, too.
Right. Okay. So something with a pH of 7 is going to be
neutral. That's like water.
Okay. All right.
Yeah.
All right. So
another thing about acids, we got that they have more H+, more hydrogen protons.
Okay.
Than they do have OH.
Okay.
Than OH minus. They have more hydrogen protons than they do hydroxide ions.
So if I put those two together, I would get water, right?
You would.
Okay. All right. That's neat to know. Okay. What about bases? Is it safe to assume they have more OH?
Yep. They'll be the opposite. More OH minus than H plus protons.
All right.
And we'll talk about more specific what those are locally.
So if I saw a picture with a bunch of OH negative ions floating around and a few H plus ions, I'd know it's a base then.
Yes, exactly.
Okay. All right.
Another thing about acids is that they taste sour.
Okay. Like, what do you mean, like they taste sour? Can you give me an example?
Like lemon juice.
Lemon juice.
Lemon juice is very, very acidic. You shouldn't ever actually taste acids, though.
Right.
To find out. Just take our word for it.
Right. I mean, but some of them are safe, right? Like lemon juice is acidic.
Lemonade. Lemonade's pretty safe.
Okay. Well, then, what do bases taste like?
Bases taste bitter. Can you think of anything that tastes bitter?
Coffee.
Coffee is bitter.
Yes.
And mustard.
Mustard. Yes.
Those are pretty bitter tasting. So say mustard or coffee.
Okay. Cool. How if I've got a random liquid and I want to know if it's an acid or a base, what can I do? You said I shouldn't taste it, though.
You shouldn't taste it, yeah. There are actually some safer ways to test it out.
Okay, what should I use?
We can use litmus paper.
Okay.
So it looks like a little strip of paper. You'll see some later on.
And
you just dip that in there, and if it turns red, it is an acid.
So the paper's going to turn colors?
Yeah, the paper changes colors. It's pretty fun.
Okay. So litmus paper will turn red if it's an acid.
And if it's a base, it'll be blue.
Okay.
So you can easily tell those apart, right?
Right. Yeah.
If it turns blue, it's a base. If it turns red, it is an acid.
Mm-hmm.
And you guys will get to play with that later on.
Okay.
Just this them out.
Great.
Another really safe way to test it would be phenolphthalein.
Oh.
That is a really long word.
Okay.
It's really just a type of indicator.
Okay, so it's like a liquid litmus.
Yeah, basically.
All right.
And it will remain colorless.
Oh.
In an acid.
Well, that's less fun.
Yeah, not as fun as the turning red,
okay.
Right? And then I'm going to abbreviate it for the base. Phenolphthalein will turn pink for a base. So don't get the pink confused with the red of the litmus paper.
Right.
Right.
All right. Okay. So we said acids are sour, but how do they feel? Like,
how do they feel? Yeah. Well, bases, for example, feel slippery.
Right.
Acids feel. I can't read that. Acids feel squeaky.
Okay.
Which is kind of, I mean, I don't know if you can think of, if you ever like rubbed lemon juice, it's kind of not really sticky, but it kind of
feels like it's like squeaking between your fingers.
Yes,
yeah.
acids feel squeaky.
All right.
But don't get some on you to test it out.
Right.
Right, and bases feel slippery like soap.
Right. That makes sense. I seem to remember somebody saying that soap is a base.
Yep, soap is basic.
Okay. Mm-hmm. All right.
And the last thing that's kind of fun, I guess, whenever acids react with metals, they make hydrogen gas.
Can't they eat right through metals?
They do, and it produces like a bubbling, and that bubbling is hydrogen gas.
Oh, cool. Okay.
So that's actually really fun.
All right.
But also kind of scary. They react with metals, and they produce hydrogen gas.
Okay. What if I get bases on metal?
Nothing will happen.
Oh.
Bases are kind of, they don't react with metal.
Well, that's sad. So, we've already talked about a few examples, but can we have a few more examples just to make sure we're all clear? Like, what's a good example of an acid?
So a good example of an acid would be hydrochloric acid, which is in your stomach.
Yeah, well, that makes sense that hydrochloric acid would be an acid.
HCl or stomach acid.
All right.
That's what your stomach uses to break down food to eat. And then we also have vinegar, which you've seen before, right?
Right.
Did you know that was an acid?
I did, actually. I knew that they use it to preserve cucumbers.
That's right, They pickle stuff, right?
Yeah.
They pickle stuff like that.
Right. All right, what about some examples for some bases?
Well, we got NaOH, which is drain cleaner.
Ooh, okay. I hear you're not supposed to put that on your skin.
Yeah, you should not drink it either.
Right. Okay.
Don't drink that stuff. And we also have chalk, CaCO3. That's a base.
That is a base. Okay.
There you go. So you got some pretty specific examples right there.
Okay.
You've probably seen it in real life. Well, I'm sure you haven't seen your stomach acid.
Yeah. CaCO3 is also what makes up limestone, which we have a lot of around here.
That's right. We have a lot of that in Texas.
Okay.